So this is my summary video. I'm going to do it with my peer Andrew. So here we can see a physical model I made which shows the straight line elements. So you can see that there, Andrew, the red string and the blue strings.
Yeah, very good, that's clear.
They represent the straight line elements, and we can see then how our curved surface inside here is formed. That's also a doubly ruled surface. It can be a warped surface as well, which can't be developed. So here as well then, it shows how the hyperbolic paraboloid can also be a surface of translation. So we have our downward parabola here, which slides or translates along our upward parabola and gives us our curved surface in there.
So, Mark, you tell me, what would you use this resource from within a school?
I made it probably as a visual aid because like students can come up, walk around the physical model, and they can mess around with it and see. I'm just going to show you now as well another model I made. It's a SOLIDWORKS model. I just feel it complements the physical model I made as it just shows an extra bit of detail. So we can see there we have our plane director. And the most important thing about that is that if we look in, see that there now, Andrew, we look in and our elements appear as parallel.
And Mark, you tell me, did you study this topic for the Leaving Cert?
No, I didn't. I had to do quite an amount of kind of research and just kind of wrap my head around it because this is probably the most difficult part. And I suppose looking into skew lines kind of gave me a very good understanding because it's the exact same principles as proving skew lines as parallel for finding the plane director. So I'm just going to show you now my assessment question I made. So it's I modeled it. I designed it off a model for an old auto car sales showroom. So you can see that. Yeah, it's the exact same. You can see how the straight line elements in there are making up the curved surface. I just thought that was a nice thing to show as well. So in the question, I wanted the students to complete the given plan and draw the elevation using 6 elements in both directions. And for part B then I was kind of throwing them in at the deep end. I wanted them to find the traces of the plane director for the edges A, B and CD. Part C then, find the curvature of the roof along the line AD. So like I asked this question, if students didn't get part B, they could still do part C, so they could pick up marks, you know. And then part D was just a STEM question I wanted to include because I think it's becoming more and more important. So I'm just going to jump in now and show you the solution. So that's our solution there to the question. You can see solution to part A, we've our completed elevation and plan. We can see how our elements are divided up in both the plan and elevation. I think SOLIDWORKS is very efficient. Yeah, it's a very good tool to use because I can turn on and off the layers. You know, I can show the different construction methods in quite easily, like for students. If you look at part B, then our solution, we can see how we use the same construction method as proving skew lines as parallel for finding the plane director. So you can see we're just making a copy of that line AB, taking a level line from C, projecting it down to plan, and taking a copy of the line AB from D. And you can see then when we extend C through that point, that's our angle we're looking in at to see our plane director. And we know it's our plane director we found because our elements are appearing as parallel. So there's our edge view of our plane director then because we know it's containing the element C, D. And there are traces in the vertical trace, horizontal trace. Yeah, I've gained a very good understanding, I suppose, from putting in the hard work. But I can see then part C, we have our curvature of our line, and it's just basically an auxiliary elevation. So we're taking our heights from the elevation and stepping them off here then. Projecting out perpendicular to the line AD, and our X2, Y2 is parallel to the line AD. And then the solution to part D, I just want the students to kind of introduce them to more engineering and construction based problems, kind of setting it in the context of the real world, giving them a solution that they'd have to think like. So yeah, I just thought that was it, and it was a nice question to ask at the end. Thanks.